Hi guys, welcome to our tech talk. So our project is that we create a website content watcher. We realized that the problem with when you refresh a page, whether it's a new site for a particular event or a for sale page like Craigslist, checking for an item or a subreddit when you're looking for like a keyword, it can be quite annoying to like constantly refresh the page and have to like check for something to finally show up. So our solution to this problem was to create a website content watcher. So this program basically was one that a user can use to enter a URL. For example, if they entered like New York Times or like a different website where they're trying to buy an item off a for sale page, and they can search for that term or topic by putting in a keyword and choose the time frequency, say like every 5 minutes, and then refresh the content watcher and it will show how many times that particular topic or keyword appears on that site. So going into our team, I'm Sanjana. I am working on the query entries and scheduler and also worked on connecting the different parts of like the front end and back end.
I'm Anjelica. I worked on the scraper, notifier, and editing the demo videos.
Oh, I'm Nikhil. I worked on the query entry, the notifier, and the HTML index files.
So I'm Victor, and I worked on the scheduler and connecting that to the scraper, so primarily backend stuff. And our mentor was Varun Mangalik. So I'm going to be going over the system and design of our content watcher. So there were four main components of the content watcher: the query entry, the scheduler, the scraper, and the notifier. So I'm going to go over this in order. So firstly, we have the query entry. So this allows us to enter information onto the site. So if you watched our demo day video, you would notice that we have information to enter, such as the website's URL, the topic, and a search frequency. So the query entry part of our project allowed users to input that information in. And once that information is put in, it is sent to the scheduler. So this scheduler schedules the scraper to get results back at a certain interval of time. So depending on the frequency that the user entered originally, the scheduler will try to work accordingly based on that frequency. Then we have the scraper, which parses through the HTML of the website to search for a topic. Basically, it's kind of like this just basically scans through like the website's code and tries to search for the keyword that a user inputs. And after all is said and done, we have the notifier, which just shows all the results that the user wants in a query manager.
So the architecture of our four systems. So each of the four systems ran on their own server that we all had to run at the same time. So first off, we have the query entry accepting information from the user, and that information is sent to the scheduler. And after the scheduler accepts that information via a post request, it then sends that info, specifically the website and topic, to the scraper. And then later on, whenever a user needs something, the notifier will send a post request to the scheduler asking for the results. And when we ask the scheduler for results, at that point, we'll take the results from the scraper, where the scraper that goes through the website. And then after that, the scheduler returns all the results to our notifier, which will display them all in the query manager. So the two main languages we used were Python and HTML. And with Python, we use several different packages, such as Flask to run our server's requests in order to send different information to our systems. Beautiful Soup, which allowed us to parse through the HTML in the scraper. JSON, where it helps us convert the data. And AP Scheduler was used with our scheduler to assign the frequencies. And to design our HTML indexes, we used Bootstrap, jQuery, CSS, Ajax, and JSON, which Nikhil will elaborate more on. So here are two examples of code so on the left, we have some code from our scraper, and on the right, some code for our scheduler. And you can see at the top, all the different packages we had to import in our terminals and in our code to make sure it's all running. And you can see with that, our beginning has, both of them have Flask. So we can create those servers that will run this code.
So I used HTML and CSS to code the following files, and the file on the left is called index.html and the right is called queries. And so they are both links that you can see on the website. When you go to, like, the first link you open is index, and then when you click the query manager, that's the queries.html. So to code both of these files, I use basic HTML and CSS, as well as jQuery to manage all the text boxes and buttons for inputs. And so for the query manager, I use to build built-in HTML plugin called Ajax, and this allows the user to send or delete a post request. And so one of the functions of the query manager was to delete a post request, and using the input that I got from the scheduler, and the input would include things such as topic, the website URL, and the search frequency, and how often you search for a term. I was able to combine all of the Ajax and HTML code in queries to allow a user to delete a query entry from the query management system. And so as for the lessons learned, we learned more of how to work as a team and communicate over Slack and video calls, working around each other's time. And so using that, we were able to develop off each other's strengths and weaknesses. We were able to brainstorm really well and get a project working successfully over the course of the 4 weeks. And so we also collaborated using GitHub. And so we don't really have that much experience out of maybe an intro CS class or something, but we were able to learn actually a lot through GitHub and like how to share files and how to add to each other's code and stuff like that. So it was really useful experience to learn that. And so we were also able to run with that. We were able to learn to run each other's codes and stuff like that. And finally, we were able to learn conducting our own research on Google and teaching ourselves how to implement things. So we were able to, like, when we had a problem, we were able to use the resources we had online to develop a final solution that worked out for everybody successfully.
So after all is said and done, there is a possibility that we could develop this project even further. So here are 3 possibilities, one of which involves the cloud. Should we ever upload our program to the cloud, this will basically give its own domain and site, and it pretty much makes it a lot more accessible to pretty much everyone on the planet. Another option we could implement is a user login feature, in which people have some sort of username, and then they use their password to secure information and possibly access queries that they were once interested in. And very finally, we have an email option. So during demo day, there was an option where you could enter your email, although that was, at the time, that was kind of just like sitting there. However, we could implement this email feature and actually have it do something by sending back results for easier notification access.
And here are some of our team contacts if anyone ever wants to reach out to us for anything. Right there.
And thank you for listening. We'd like to give a special thanks to Code Day for providing us with this internship, and thank you, Varun, for all the help you've given us.